You know how it is in the world of data, right? You get handed this raw, messy pile of numbers. But how in the world do you turn that chaos into a story that actually makes sense? Well, today, we're diving into exactly that. And that really is the million-dollar question, isn't it? For anyone working with data, how do you find the meaning that's hiding inside all those numbers? And believe me, this isn't just about running a program. It's an art. It's about asking the right questions.
And this is what that journey looks like. On one side, you've got the raw information, just a jumble of figures in a spreadsheet. And on the other, you've got the goal, that beautiful polished dashboard where everything is crystal clear. Now this transformation, it isn't magic. It's a methodical process, a real craft called exploratory data analysis, or EDA for short.
Okay, so to kick off our investigation, we need the right tools. I want you to think of yourself as a data detective. And your first and probably most powerful tool for separating the important clues from all the random noise is statistics.
And this is the core idea right here. Statistics isn't just a bunch of scary math formulas. It's a way of thinking. It gives us the rules of the road, a framework that helps us separate the real, meaningful patterns from just random chance. It stops us from jumping to the wrong conclusions.
All right, with that in our back pocket, let's actually open up our toolkit and take a look at the fundamental concepts that every single data detective needs to have mastered.
First thing we're going to grab is descriptive statistics. This is like the initial sweep of a crime scene. You're not solving the whole case yet, just getting the lay of the land. What's the average age here? How much does the income vary? It just gives you a high-level summary of the facts on the ground.
Next up, we've got statistical inference. Look, a detective can't interview every single person in a city, right? It's impossible. So they interview a strategic sample of people. Well, inference is the tool that lets us take what we learned from that small sample and then make a really confident, educated guess about the entire city. It's how we generalize from the evidence we actually have.
So think of this table as our detective's cheat sheet. It lays out the whole strategy. We always start with descriptive stats just to get a feel for the data, to build our intuition. Then we might use probability models to figure out uncertainty and risk. And finally, we use those inference methods to take our findings and build a credible, solid case. It's the whole shebang.
All right, enough with the theory. The best way to learn detective work is to actually get our hands dirty and crack a real case. So let's open up our case file, a real-world data set all about diabetes.
So, here's the lowdown on the case file. We've got data on 768 different patients. And for each person, we have clues like their glucose level, their blood pressure, their age. Our job? It's to use these clues to predict that final outcome, to figure out if they have diabetes or not. So, the first thing any detective does is run a standard check for missing evidence. The computer runs a quick command, and it comes back and says, 0 missing values, across all 768 records. The file looks perfectly clean, so we can pack up and go home, right? Well, not so fast. A good detective knows that the most important clues are often the ones hiding in plain sight. It's time to move beyond those automated checks and start dusting for fingerprints. And this is exactly where that human intuition, that detective's eye, becomes absolutely critical. You know, the analyst in our source video really hit the nail on the head here. We often just trust the initial numbers and assume the data is clean, but the real insight, that comes from looking closer. And boom, there it is, the smoking gun. As we just scan the data with our own eyes, we find patients with a blood pressure value of 0. Now, think about that. A living person cannot have a blood pressure of 0. This isn't just a missing value, it's an impossible value. This is the kind of clue a simple automated check will miss every single time. So, what do we do about these bogus zeros? We can't just leave them there. We've got two main options. We can replace them with the mean, which is just the average value, or the median, which is the value smack in the middle. Now, the mean can be tricky because it's really sensitive to extreme values. We call those outliers. Like if one person in a group earns $1 million, the average income for the whole group gets pulled way up. The median, though, it's not affected by that one outlier at all. So, since outliers can totally distort our picture, the median is usually the safer bet. But hold on, how do we even spot these outliers in the first place? Well, we need to actually see the shape of our data. And this is where we pull out, honestly, a detective's most powerful technique, visualization. It's trying to turn these numbers into pictures so we can really start following the leads. And a perfect tool for the job is something called a box plot.
This chart gives us a super quick snapshot of how our data is spread out. See, most of the values fall inside that main box and its whiskers. But any data points that fall way outside, like these little dots here, those are our potential outliers. In our diabetes case file, the insulin column was just full of these, which totally confirmed that using the median was the right call.
Okay, another killer visual tool is the correlation heat map. This chart is awesome. It shows us how strongly all of our different clues are related to each other. The brighter the color, the stronger the connection. It's basically like creating a relationship map for all the evidence in our case file.
So why does that matter? Well, because if two of your clues are highly correlated, they're basically telling you the exact same thing. It's like having two witnesses come in and give you the exact same testimony. A good detective knows you can dismiss one of them and focus your energy on the unique, independent clues to build a much stronger case.
And just like that, we've totally transformed this case file. We started with a data set that looked perfectly clean on the surface, but then we uncovered hidden errors, we visualized the outliers, and we identified redundant clues. We are now ready to crack this case.
So, let's just quickly recap the data detective's playbook, shall we? 1. You start with an initial sweep to understand the basics. 2. You find the clues, hunting not just for missing values, but for impossible values. 3. You follow those leads with visualizations to spot outliers and relationships. And finally, 4. You clean the scene by fixing those errors and focusing only on the most important evidence.
When you get right down to it, every single data set has a story that it's just dying to tell. Exploratory data analysis, this whole process, it gives you the tools to listen, to separate that signal from the noise, and to uncover the truth that's hidden inside. So the only real question left is, are you ready to listen?